Right now, as you're watching this, your brain is quietly losing a war it doesn't know it's fighting. In 2004, the average person could focus on a single screen for about 2.5 minutes. That was the baseline. Today, 47 seconds. That's the finding of Dr. Gloria Mark, a researcher at the University of California, Irvine, who has tracked attention spans for over 2 decades. Your environment has been engineered to break your focus, and your brain is responding exactly the way it was designed to. In this video, I'm going to show you why and what to do about it. To understand why your focus is disappearing, you need to understand one chemical, dopamine. Dr. Anna Lembke, chief of the Stanford Addiction Medicine Dual Diagnosis Clinic, explains that dopamine isn't really about pleasure. It's primarily about anticipation, the wanting, not the having. Your brain cares more about what might happen than what already did. Your brain releases dopamine not when you get a reward, but when you expect one might be coming. The moment before you open a message is more neurochemically powerful than the message itself. And every time you open an app, your brain doesn't know exactly what it's going to find. A new like, a comment, something surprising, nothing at all. That uncertainty is the trigger. That unpredictability is exactly what drives the dopamine release. It's the same mechanism that makes slot machines addictive. Psychologists call it variable reward scheduling. And your phone is the most efficient slot machine ever built. It's in your pocket 24 hours a day. The more you check, the more your brain trains itself to seek novelty instead of sustaining attention. You're building a habit loop you never consciously agreed to. Every scroll reinforces the pattern. Dr. Adam Gazzaley, a neuroscientist at the University of California, San Francisco, calls this the interference problem. Your ancient neural wiring is fundamentally mismatched with modern digital environments. The human brain did not evolve to resist the kind of stimulation our technology produces. We have Stone Age biology running against 21st century software, and the software is winning. Our prefrontal cortex, the part responsible for sustained focus, planning, and self-control, is being constantly interrupted by signals it was never designed to filter out. It's not that you lack willpower. It's that your brain is running software built for a savanna, and you're living in a world that fires 1,000 notifications a day. And what makes this worse is what happens next. Because when you give in and check that notification, the damage doesn't stop there. The real cost isn't the 10 seconds you spent reading the message. It's what happens to your attention after you put the phone down. It lingers. It bleeds. Think of it like a single drop of ink falling into a glass of perfectly clear water. Even one drop changes the color of everything. What happens after you check that notification is actually worse than the interruption itself. And almost nobody talks about this. Dr. Sophie Leroy, a researcher at the University of Washington, discovered a phenomenon she calls attention residue. When you switch from task A to task B, your brain doesn't fully switch. A piece of your attention remains stuck on the previous task, like a residue you can't wipe away. Part of your mind is still back there, processing, wondering, unfinished. And the more frequently you switch between tasks, the more residue accumulates. Each switch adds another layer of cognitive fog. Your cognitive performance degrades with every switch. Not a little, significantly. The decline is measurable, consistent, and predictable. This is why you can spend an entire day working, checking emails, responding to messages, jumping between tabs, and feel like you accomplished absolutely nothing, because in terms of deep, focused work, you didn't. Dr. Gloria Mark's research found that after a single interruption, it takes an average of 23 minutes and 15 seconds to fully return to the original task. Let that sink in. 23 minutes from one interruption. Now think about that. If you get interrupted just 4 times in an hour, the math is devastating. The recovery periods overlap. You never actually reach full focus at any point. The entire hour is residue. That invisible weight, the unfinished thoughts, the half-processed messages, the lingering context from the last distraction. It compounds and sits on you all day long. And yet, most people's response to feeling scattered and unproductive is to try harder, to multitask, to open more tabs, to power through. But here's the problem with that strategy. Your brain is already drowning in residue. Multitasking doesn't solve the attention problem. It multiplies it exponentially. If distraction is the disease, then multitasking is the lie we tell ourselves about the cure. Dr. Earl Miller, a neuroscientist at MIT, has been blunt about this. The human brain cannot do 2 cognitive tasks at the same time. It is neurologically impossible. Full stop. What you think of as multitasking is actually rapid task switching. Your brain is flipping back and forth between tasks, not running them simultaneously. And every flip has a price. Every single switch carries a cost, a toll on your cognition that you pay whether you notice it or not. Research shows that when people attempt to multitask, their error rate increases dramatically and the quality of work on every task drops. You're not getting more done, you're getting less done, worse. And here's the part that should concern you. You are literally rewiring your brain to be worse at focusing. Remember the synaptic pruning concept from our earlier video. Your brain strengthens the pathways you use repeatedly and deletes the ones you neglect. Use it or lose it. If you spend your days switching constantly, your brain optimizes for switching. It builds a superhighway for distraction and lets the roads to deep focus crumble. Meanwhile, the circuits for deep focus begin to atrophy. The synapses weaken, the connections thin, they deteriorate from neglect. So the real question is, how do you take control of this? How do you stop the damage and rebuild what's been eroded? Here are 3 strategies backed by the neuroscience we just covered. Strategy 1. Create transition rituals. Before switching tasks, take 30 seconds to write down exactly where you are and what your next step will be. This simple act closes the cognitive loop and dramatically reduces the amount of attention residue that follows you to the next task. Strategy 2. Protect 90-minute focus blocks. During these blocks, your phone goes in another room. Notifications are off, not on silent, not on do not disturb, off. You are creating a physical environment where deep focus can actually happen. Strategy 3. Move your body to reset your brain. Dr. Marilia Petso at Stanford University found that walking increases creative output by an average of 60%, not 1%, not 5%, 60. Walking activates your brain's default mode network, a restorative state where the accumulated residue from your work session begins to clear. Your neural pathways reset and consolidate. You return to your desk with a genuinely refreshed prefrontal cortex. Not just rested, rebuilt, ready to do real deep work again. The environment you build around yourself is the architecture of your attention. It's not a detail, it's the foundation. Design it deliberately. Your attention is not broken. It's being stolen, every single day, by design, by systems built to capture it. But you can take it back. Every uninterrupted focus block rebuilds the circuits for deep concentration. Every transition ritual clears the residue. Every walk without a screen lets your brain do what it was originally designed to do. Think deeply, solve problems, and create. You are not your environment, but you are shaped by it every single day. So shape it deliberately. Your brain will follow. That's how you reclaim your focus.